Okay, so good morning, good afternoon, or good evening. Kung anong oras mo man pinapanood ang pre-recorded video na ito, good day sa'yo. So, our topic for today is Gravimetric Analysis. So, first, we have to know what is Gravimetric Analysis. Gravimetric Analysis is a technique in which the amount of an analyte in a sample is determined by converting the analyte to some product. So, ang analyte is the compound or species to be analyzed in a sample. So, dito, technique siya na kung saan aalamin natin yung percentage by mass ng isang analyte sa isang sample by converting it into some product. So, for example, meron tayong water, a glass of water. Tapos, nalaglagan siya ng cereal. So, natunaw yung cereal dun sa water. So, we wanted to know the percentage by mass of that cereal dun sa natunaw na water by converting that cereal into a some product. Okay? So, later, I'll discuss to you paano natin mako-convert yung cereal na yon na natunaw dun sa water into some product. Kasi di ba natunaw na siya dun sa water. So, hindi na siya makikita. Kumbaga, hindi na siya tunaw na siya. Hindi na siya makikita through naked eye. But it's still there. Pero hindi nga siya makikita through naked eye kasi natunaw na siya. So, I'll discuss later kung paano natin makukuha or mako-convert yung tunaw na cereals dun sa water into some product. Okay? So, basta, here, sa gravimetric analysis, ang tatandaan nyo lang is it finds to find the percentage by mass of something in a given substance. Bale, siya? Analysis method based on mass. Okay? So here, next is principle of gravimetric analysis. Let's read the principle behind gravimetric analysis. Okay? The principle behind the gravimetric analysis is that the mass of an ion in a pure compound and can be determined later. Wait lang, I think there's something here. Later, used to find the mass percentage of some ion in a known quantity of a impure compound. So, bale, ang principle nito ng gravimetric analysis na it is possible na makalculate ang mass ng ion in a pure compound, then use it to calculate the mass percentage of the same ion in a specified volume of an impure compound. So, marami tayong iba't ibang ways, I think, inside the gravimetric analysis, maraming iba't ibang types. And there's this, based on my research, based on what I've searched, there's volatilization, thermogravimetric, and electrogravimetry. But we're gonna focus more on precipitation since it is the most common. So, sa precipitation, base sa akin na research, again, precipitation is a method na where unknown is isolated via precipitation and filtration. So, ang precipitation daw, yung unknown, halimbawa kanina, yung example ko sa inyo, hindi natin alam yung mass ng hindi natin alam yung mass, percentage by mass ng cereal na natunaw. So, yung unknown na yon ay para malaman natin, we're going to perform a precipitate. So, by doing precipitation, we're going to do a precipitation and filtration. So, here is a schematic. What do you call this? Schematic, they say. Schematic where it clearly shows how a gravimetric analysis, particular example of gravimetric analysis. So here, let me show you. So una, kukuha tayo ng solution na nagko-contain ng 2 plus ions. And then, that sample na nagko-contain ng 2 plus ions, we're going to dissolve it to water. Yan, na-dissolve na siya sa water. Tapos, pag na-dissolve na siya, we're gonna add another aqueous solution. From that, yung aqueous solution na yon is, it contains ion as well. So, Pag dinagdag mo yan doon, magkakaroon tayo ng precipitate. Okay? So, once na nagkaroon ng precipitation, that lead 2 plus ion, in this case, that ion is sulfate. So, the sulfate combined with lead 2 plus to form a solid lead sulfate. So, halimbawa, here, nag-ano na siya, diba? Nag-combine na siya. May ma-form dyan na parang, what do you call this? Parang clugs. Later, I'll show you, may video ako na nahanap sa YouTube. I'll show you kung paano siya, anong itsura niya. So, ano muna, picture muna. Here, wait lang, I'll show you the instruments. Yan. So, components and parts of instruments. Here, yan, di ba yung itong solution na to? Here, this solution, ilalagay natin siya sa dito, sa funnel na to, dyan. And then, mafi-filter siya ng paper, filtered paper. So, ang una natin gagawin dyan is, kukunin natin yung mass ng fake paper. So that, mamaya, pag nakuha na natin yung precipitate nung solution na to, by filtering this into here, alam natin kung ano yung ma-minus or babawas natin dun sa nakuha nating mass. So, ilalagay natin siya dito, tapos mag-filter siya, tapos yung matitira dito, yung sabi ko sa inyong clogs, yung parang clogs, may ano kasi siya video mamaya, I'll show you. So, once na nakuha na natin yon, natapos na siyang mag-filter dito, nalagay na lahat ng water, may maiiwan dyan. So, yun yung idadry natin. Tapos, after natin i-dry, yun yung kukuhain nating mass. And pag nakuha na natin yung solid na yon, that is where we're going to perform the stoichiometry. Okay? So, here. Okay, so sorry for the sudden change kasi I need to finalize something. So, here, so sample computation natin, student wants to determine the concentration of barium ions in 100 milliliter of an unknown solution of barium sulfate. So, first, we have to determine what is our precipitate. So, para nalaman natin kung ano yung mass, kung ano yung kukuhaan natin ng mass. So, here, ang ating precipitate is the barium sulfate since it is a insoluble salt. So, by that, gagawin natin yung process kanina, yung kung saan gawa tayo ng filtration and such. At for example, dito sa example na to, ang nakuha ni student is, what do you call this? Nakuha niya is 2.917 grams. So, ang stoichiometry, mag-start sa 2.917 grams of barium sulfate converted to mole using converted to using the molar mass of barium sulfate. So, according to the balance equation, for every 1 mole of barium sulfate formed, kailangan natin ng 1 mole of barium ions. Wait lang, may maingay sa background. Okay, so sorry, may dumaan kasi na may nag-speaker, something like that. So, asan na ba tayo? Yun. So, yun nga, according sa ating balance equation, sa every 1 mole of barium sulfate na na-form, kailangan natin ng 1 mole of barium ions, which means we have 0.01250 mole of barium ions that we precipitated out. So, tatandaan natin na kanina, dito sa ating problems, dito sa word problems natin, kailangan nating malaman yung it was in 100 milliliters of solution. So, kailangan natin siyang i-divide by 100 milliliters. So, ito nakuha nating 0.01250 mole of barium ions. Kailangan natin siyang i-divide into 0.100 liters, and that will give us 0.125 molar. Okay. Kailan di pala naka-on yung cam. Anyways, there. I'm sorry, hindi pala naka-on yung cam. And then, next, I hope you get that. Here, components and parts of the instruments. Yan. So, dito, we have a butcher funnel. Ano ba? Embudo. Embudo. Yan. Para siyang embudo. But more, mas maliit. Then, tas paper, yung filtered paper, isa siyang circle na paper na we're gonna use as a filter. Tapos, vacuum flask. Meron akong nakitang video na may vacuum source, but ang example video ko na ipapakita sa inyo is wala siyang vacuum source. And here's the video. Here, how it works. Here, preparation of solution. I think it's much better if you'll see how it's being done. I have a video here na nahanap. Wait, I'll show you. Wait, let me just...
In your next experiment, you guys are going to be performing a double replacement reaction. And so you'll be taking two solutions, like these, mixing them together and forming a precipitate. But you want to examine the precipitate. We've talked about how the precipitate's the real important part of the double replacement reaction. And so to examine the precipitate, you need to be able to measure it, which means separating it from all of the liquids that are involved, all the solutions that are involved. In order to do that, we're going to perform a technique called gravimetric analysis. And so gravimetric means measuring using gravity. It's just a fancy name for filtering it. And so we're going to take our solution, our reaction mixture, with our precipitate and solutions in it. We're going to use a funnel and an Erlenmeyer flask and some filter paper to filter our solution so that we can separate the precipitate from everything else. So in order to do that, first we need to perform our reaction. And so I got a little beaker to mix everything in. And in my example, I have nickel 2 nitrate, which is a nice green color, and sodium phosphate, which is clear. So I'll take the nickel 2 nitrate, just add some to my little beaker. And then I'll take the sodium phosphate, add some to the beaker, and I'll get a nice light gray precipitate. So whatever precipitate you have, this is what you care about, all that cloudy stuff in there. So we need to remove that and we need to measure it. When we filter it, everything is going to get caught, all the precipitate is going to get caught by the filter paper. So we'll pour it into the funnel, we'll put the filter paper in here, pour it in, and then everything will get caught in here, and we'll want to find the mass of it. But that means the filter paper will be included in that mass. We want to take that into account, and so we need to measure the mass of the filter paper first so we can subtract it in the end. But you're not going to be the only ones performing this experiment. You want to label that this piece of filter paper is yours, so you can just put your initials up there, put the initials of your group members there. That way it's done. So then we have our filter paper ready to go, ready for the experiment. Now we're going to find the mass of it. So the balance, press 0, and then put the filter paper on. This piece has a mass of 1.01 grams. So you should have a data table set up already. Mass is 1.01 grams. Okay, so now we have our filter paper. So we're going to put it in our funnel. Now we could just kind of like shove it down in there, but that's really unprofessional and doesn't work really well. I mean, it's going to make you look like you have no idea what you're doing, and if you watch this video, you'll have some idea what you're doing. So instead, we're going to take the filter paper, we're going to fold it in half. They're hamburger, hot dog style. It doesn't really matter what you call it because it's a circle. It's the same. And then we're going to fold it in half again. So now we kind of have these 4 layers of filter paper stacked on top of each other. You're going to pick the layer on either end, so like this one for example, and then the layer next to it, separate them apart and hold the other 3. and then you're going to have this nice little pocket. And so if you notice, you have a that's now the same as the funnel. So we're just going to take that cone, put it in the funnel. Doesn't really want to, it wants to be flat again, and the funnel's round. And so we're just going to hold it in, take some distilled water, some moisture on the sides of that, and now it will stay in place. So you can already see the water starting to drip through. So that'll happen as you're filtering it. You're just going to have the precipitate in there. So now we have our flask ready to go. Our filter's all set up. And so we're just going to take our precipitate and, well, our reaction mixture, all of it, and we're going to pour it in. We want to get every little bit in. So that includes everything that's left in here. We don't want to leave any of the precipitate behind. So we'll just take our distilled water, rinse that out, and dump it all in. Okay. So now, the exciting part comes. We're just going to wait for all of that to drip through. And so, at least most of it to drip through. It would take us forever until all of it actually dripped through. So you're just going to wait maybe like 10 minutes, maybe more, until you can hardly see any water left at the bottom. And so we're going to time lapse this a bit, put that off to the side while it continues to drip. And then this is a previous one, and so you can see there really isn't any water left. It's not going to like pour out when I turn it upside down. And so that's ready to dry. So we don't want to wait days for this to dry, and so we're just going to we're really just going to settle for 1 day. We'll start the experiment 1 day, and then we're going to put the filter paper in a drying oven to dry. So I have the drying oven right here. You'll have to go to the one that's set up in the room, or it'll be in my prep room because this is the only one we have. So we'll go to the drying oven, open it up, and then you're going to take your filter paper, spread it out. It's already labeled, so you won't get it confused with anyone else's, and you'll just put it in there until the next day. Then the next day, it'll be dry. You'll take out your piece that you put in, and you can see all the moisture has dried off. The paper is very like crispy kind of. And then we have this solid precipitate on there. It looks kind of like dry, cracked dirt that used to have water on it. Yours probably won't be this color. Or it probably shouldn't be this color. So we'll take our filter paper with the precipitate. We already know the mass of the filter paper, so any additional mass is the precipitate. Put it on the balance. We have a mass of 1.42 grams, so record that. And then some quick subtraction. That means the precipitate has a mass of 0.41 grams. So now we can use that mass to perform our calculations. Stoichiometry, the best part of the experiment, right? And so you don't need the filter paper anymore as long as you have the mass of the filter paper recorded in multiple places, maybe by multiple group members, maybe like on paper and electronically, or maybe like if it's electronic, your Google Drive should save it, and so you should be safe. But once you know everything's good, you can throw the filter paper away. Don't need it anymore. You don't need this anymore, and then you can take all of the solution that's in the flask, and you can just dump that down the sink.
Okay, so as you can see there in the video, that solution here, na kinawa natin kanina, is being filtered by this apparatus. So, nilagay dito yung, wait, let me just, here. So, nilagay dito yung solution, and then, na-filtered siya, tapos kinuha yung kumbaga, ang tawag nito is, na-precipitate, kinuha siya, and then, it's heated, nakita nyo sa video, nilagay siya sa oven, parang oven siya, drying oven, something like that. Tapos, after that, kinuha niya yung mass nung nakuha niyang substance. Bale, that's the process of that's the process on how to use this gravimetric analysis apparatus. Bale, basically kasi, ang gravimetric analysis, sabi niya nga sa video, it's actually a pinagandang word for filtration. So, basically, it's just a filtration. But yung paper here, yung filtered, nakita nyo na sa video, yung filtered paper, kinuha niya yung mass. Since kasama nga siya dun sa pag-weigh, pag natapos na siyang madry, i-weigh siya, diba? Kukunin yung mass. So, kailangan alam natin yung timbang ng paper bago natin siya malagyan ng another contents, which is yung nakuha nga natin dito. Para ima-minus natin siya. Katulad ng ginawa niya sa video, minus niya yung sinubtract niya yung way nung paper before para alam niya kung ano yung ima-minus niya dun sa nakuha niyang substance. So, that's it. That's how it works. Here is the application and use. Wait a minute. Okay. So, its application and use. Wait lang, may maingay. Okay, so lastly, its application and use. So, in analytical chemistry, gravimetric analysis is a way of determining the analyte quantity based on the density of solid. Example, measuring the solid suspended in water sample and collected solids are weighed until the known water volume is purified. So here, ano lang na to, pag sa real life explanations, ano bang dulot niya sa real life? Example dito is yung pag purified ng water. Diba may mga hindi naman natin masasabi na yung water is, yung water dun sa gripo natin na lumalabas is a purified water. So, yung nabibili natin sa market, yun yung dumaan sa filtration. So, yun ang isa sa mga tulong ng gravimetric analysis in our daily lives to filtered water, to make purified water. That's it. I hope you learned something. That will be all. Thank you.